You know, the universe can be a dangerous place to be, but you're probably thinking about killer asteroids. But did you know that there are also killer supernovae? So, is humankind threatened by a nearby supernova? We'll have to take a dive to figure that one out. As long as fusion reactions occur in its core, a star remains stable against the ever-relentless gravity of its own mass. Just like the pressure that builds up inside a balloon as we blow air inside fights the tension of the gum, the pressure that comes from fusion reactions in the core fight gravity. But what happens when a star runs out of fuel and fusion reactions stop? The collapse begins. If a star is about 10 times more massive than the Sun, nuclei in its core start to disintegrate under pressure, and protons and electrons have no other option but to start combining into neutrons. Tight neutrons are the last line of defense against the collapse. And as the infalling layers of the envelope of the star run into the neutron floor, they bounce. The bounce sends a shockwave that rips through the star, and although scientists are still debating the true mechanism of this process, we know that it results in a star exploding as a supernova. Supernovae are as bright as hundreds of billion stars shining together, but that radiation is actually only about 1% of the energy that goes into the explosion, which is like 10,000 billion Hiroshima bombs combined. And you really don't want to be near that. But have we ever been? Every century, 2-3 massive stars explode as supernovae, but the most massive stars are far away. But how far is far enough? Supernovae are producers of energetic particles called cosmic rays that can rain on Earth for 100,000 years, causing damages to DNA. Together with X-rays and gamma rays, they could also destroy the ozone layer in the Earth's atmosphere, leaving all life on Earth unprotected from harmful solar UV radiation. The distances at which these effects would cause mass extinction are closer than 25 light years. And that is the kill zone. Comparing the volume of that kill zone and the volume of the entire Milky Way, and assuming that roughly 2 stars explode as supernovae every 100 years, we can estimate that supernova event that could cause mass extinction, the killer supernova, happens in our neighborhood once every billion years. This means that the Earth has potentially witnessed 4 killer supernova events during its 4.5 billion year long lifetime. But to find evidence, we first must go up back to our explosion. Here we can see that supernovae are not just explosions, they are also element factories. Iron that makes our blood red came from exploding stars. So we basically bleed star stuff. Iron-60 is another version of iron made in supernova explosion, but this one is radioactive. This means that it decays, it turns into nickel-60 in about 2.5 million years, but because Earth is 4.5 billion years old, finding this iron would mean that it was freshly made in a nearby supernova explosion. And this is what we are looking for. And now we must dive 4,830 meters below the surface of the ocean. Welcome to the deep ocean crust. The reason why we are here is because this crust is like a time capsule. It records events of a time and logs them in. But it also records time in its layers because its thickness grows over time 1 millimeter every million years. So when we drill down and take a sample from this crust, each layer tells a story of a different time. And this is where the smoking gun, or should I say smoking iron, of a nearby killer supernova was found. The iron-60 found in the crust came from a star 10 times more massive than the Sun that exploded at about 150 light years from us some 2 to 3 million years ago. And you know, that means that our cousins, Australopithecus afarensis, were there to witness it. But what about future explosions? Do we live in a safe neighborhood? Luckily, there are no ticking bombs within the 25 light-year kill distance from us. Actually, the closest star to us and to its great explosion is Betelgeuse, a red supergiant in the constellation Orion at 640 light-years from us. It is expected to explode sometime in the next 100,000 years, but at this distance it will cause just a spectacular light show and nothing else. However, since the Sun and Earth with it is revolving around the center of our galaxy, which takes roughly 250 million years, our neighborhood might change dramatically in a few million years from now. And now, let's put our gamma ray glasses on to reveal the neighborhoods where there have been recent supernova explosions in the galaxy, as will be explained in the next video of Astronuclear Nibbles.